Alright, so this video is going to focus on the electrical end of my compressor setup. We're probably going to focus more on this one than the other one because the setups are pretty much the same. This is a 5-horse WEG motor that runs this compressor. This is what I call compressor number 1. And what we have here, this is a 220 motor, single phase. It runs, I have 6 wires coming through here. I have 2 power wires and a ground going to compressor 1. I have 2 power wires and a ground going to compressor 2. So it comes down through here and comes up into the motor controller. So the motor controller is a contact, and this is good for a 5-horse motor. And the contact is controlled by this switch. So this switch, based on pressure, either pulls this contact in or lets it go to break the contact. And it's all based on pressure coming through this switch. So the full amperage that this engine, or this motor, draws is about 20 amps or so. The full amperage does not go through this switch. This switch is totally totally pressure based, and it turns this contactor on and off, which turns the motor on and off. So the reason for doing that is if you put the full amperage through a switch like this, what'll happen is that switch will probably burn up and you'll be replacing it on a fairly frequent basis. So that's why we have this motor controller here with a heavy duty contactor that starts and stops this motor when needed. So alright, so down here, this is our continuous run valve. You know, if we turn this on, we are in continuous run mode. If we turn it off, it's start and stop mode. So we have an normally open and a normally closed switch. This one here is a normally closed switch. And what this does is this, when there's no pressure here, it is normally closed and it makes the connection, which when the compressor is running, it will light this red light. Now, if you turn this on, once the switch allows pressure to come through here and run the compressor in an idle state, once pressure comes in, it will open this switch, and this is a normally open switch, and the pressure will close this switch, and this switch will turn on the amber light, and the pressure will cause this switch to open, which will turn off the red light. Alright, so if you notice on my monitoring board here, we have LED lights, and we have hour meters, and we have the amber and the red lights. Now, I explained how the amber and the red lights work. The green lights just mean that the breaker is turned on and there is power going to the compressors. So that comes out of here and feeds through this harness, through the pecker head of the motor here, and it feeds off of the power feed off of here. So as long as the breaker is turned on, the green lights will be on. If you turn the breaker off, they will go out. Everything else, as far as the hour meter goes, the amber lights, the red lights, that all feeds off of the power here. So once the contactors connect and they start to send power to the motor, now we have power going into our switches, which decide which lights are turned on. And we also have power going to our hour meters, because if there was power going to the hour meters all the time, we'd have a lot more than 24 hours on this thing. So I also have a tach setup here, one for each compressor. This is a digital tach setup, and in order to turn it on, you can turn on this switch right here, and that switch will also turn on the box fans that help to move more air, and it will turn on the tachs, the tachometers. So the tachometers get a signal from a sensor right here, and that's a homemade bracket. If you look right above the sensor there, there's a magnet that I drilled a little recess into the flywheel and glued the magnet into. So every time it passes by, it sends a signal, and the tachometer determines RPMs based off of that. So now these tachometers are 12 volts. There is an AC to DC converter behind this panel here that feeds power to these. Now these LEDs and the wiring that feeds the hour meters and everything else is all 600 volt duty. So, and we can, like I said, we can turn this on. The tachometers come on, and if the compressor was running, you would see an RPM reading from this one or this one, depending which one is running, or both. So compressor number 2 is set up the same way. We have our pressure switch. Our pressure switch controls our motor controller, which feeds our 2-horse motor. Now this is a 5-horse motor controller, and it is wired as if it was 5 horse. And the reason I did that was because in case this 2-horse motor would have an issue or it would burn up, I would probably upgrade it to a 5 horse. So it's only a matter of upgrading the motor rather than trying to upgrade the wiring and everything else that goes to it. So these are the wiring that comes out and controls the control board. Like I said, there's 4 different wire colors. We have red, we have yellow, black, and green. You can see the green wire down here, which comes out of here to light up the green LEDs. So the wiring is pretty much the same. We have a normally open and a normally closed switch. The yellow wire goes to the amber switch, or amber light rather. The red wire goes to the red light. The black wire goes to the hour meters, and the green wire, which you can see there, the green wire goes to the green light. So that's pretty much how I set up all the electric. Like I said, the biggest thing here, what I was worried about, was these pressure switches don't usually work very well if you're trying to put a lot of amps through them. So what I was worried about was burning them up and having to replace them on a fairly frequent basis. So that's why I'm running this motor controller here with contactors inside. So both compressors have a motor controller on them. Compressor number 1 has one. And that's pretty much how I wired it. It's pretty easy to do. If you have any questions, you can leave them in the comments. Thanks for watching.